Hi everyone, welcome back. In this section, we'll bring together all that we have learned and configure the drone for flight. I've divided everything into short videos so that you can easily refer back to individual things when needed. Assuming you followed along all the steps in section 3, you might now have a drone sitting on your desk, ready to be configured. We will need to connect it up to a computer, download the latest firmware on it, and configure all the necessary settings so that it can fly. But first, let's set up the radio system. Quite often when you buy this radio transmitter, it comes with a receiver as part of a package. And that receiver is usually already connected to the transmitter, so you don't have to do any manual setting up. However, since we're using an alternative receiver than the one it usually comes with, it needs to be bound to the transmitter before we can use it. The steps to binding your receiver can be a bit confusing, so let's see how it's done. Start by making sure your transmitter is turned off. Then press and hold the bind button on the receiver while plugging in the battery of your drone. This should make the little red light on the receiver flash rapidly. Now press and hold the bind button and turn on the transmitter. You should see the message RX binding on the screen. Now notice the red light on the receiver. It should have gone from flashing rapidly to flashing slowly. If that's happened, then we have successfully bound the transmitter and the receiver together. Now all we have to do is turn the transmitter off and on again, at which point the red light on the receiver should go solid red. Our receiver supports up to 6 channels, so let's set up some aux channels next on the transmitter. The main menu is accessed by pressing and holding the OK button, and it contains System Setup and Function Setup. The up and down buttons on the transmitter allow you to move around in the menus. So select Function Setup. The only thing we need to set up here are the aux channels, so go ahead and select that. By default, the transmitter assigns the 2 dials in the middle as channels 5 and 6. What we want to do is assign some flip switches instead. The navigation is a bit confusing, but while the arrow has one of the channels selected, you can press up or down buttons to scroll through the choices. In this case, for channel 5, we are assigning switch A, which is this one-way flip switch. After you have set it to switch A, press the OK button, which will make the arrow select channel 6. For channel 6, we are assigning switch C, which is this 3-way switch. After both switches have been set, press and hold the cancel button to save. We've now set up 2 aux channel switches, which will come in handy when we go on to set up flight modes later on. Okay, so one last check before we set up the flight controller. Let's make sure that all the motors are connected as they should. Looking top down, motor 1 is the bottom right, motor 2 is top right, motor 3 is bottom left, and motor 4 is top left. Let's also make sure that the speed controller connectors are connected in the right sequence, or else the drone will do unwanted acrobatics. Looking top down again, motor 1 is the first set of pins from the right, after that it's motor 2, then motor 3, and then finally motor 4. The last plug on the left is for the incoming 5 volts that power the flight controller. Time to configure the flight controller, and we need the following things to get started. First thing we need is a micro USB cable to connect the flight controller to the computer. Secondly, you might also need to download some drivers so that your flight controller can talk to the computer. In my experience, Windows 10 detected the flight controller and installed the drivers automatically, but in case you need to download them manually, the link for the drivers will be in section 4 resources. Lastly, you need to download the latest version available of the Betaflight Configurator app. The link can also be found in the section 4 resources. Now that we have everything we need, let's go ahead and connect the flight controller to the computer. It's time to load up Betaflight and install the latest firmware on the drone. This is the first screen you will see when you load up Betaflight. The key things to note on here are the COM port. Betaflight should auto-detect the flight controller connected and auto-set the correct port as well. If this hasn't happened, double check if the flight controller is talking to the computer properly. In my case, when looking in Device Manager on Windows 10, I can see that under ports, there's an entry on COM9. So you'll be looking for a similar entry, but the COM port might be different. The second thing that's important on the screen is the firmware updater on the left. It will be the first thing we need to do when preparing the flight controller, so go ahead and press the firmware flasher so that we can upload the latest software available. Okay, so let's have a look at how the firmware flasher works. Betaflight supports many different flight controllers. When clicking on the drop-down menu where it says choose a board, you can select your specific flight controller. In this course, we're using an SP Racing F3 flight controller clone, so we can go ahead and select that from the list. Betaflight automatically fills in the second drop-down box with the latest available software for the specific board selected. Next, go ahead and click the Load Firmware Online button, which will download the firmware onto your computer ready to be flashed. Once the firmware is downloaded, click on the flash firmware to install it onto the board. If, however, you have not been able to flash the firmware, try the steps again from scratch. Confirm that the flight controller is connected to the computer and the correct COM port is selected. If you still haven't been successful, get in touch and I will try my best to help you get through it. You should see programming successful if the firmware flashed correctly. Fantastic, now we can move on to the configuration stage. Go ahead and click the connect button on the top right and you will see this 3D representation of your drone, at which point you know that the firmware was successfully flashed. Betaflight is jam-packed with so many different options and features. We will only be doing the basic setup to get the drone flying at this stage. One very important thing to remember is to never have the propellers attached to the motors during setup phase and only mount the propellers when you're ready to fly. Now the first thing we'll do is calibrate the accelerometer, which will improve flight stability. Sometimes the internal sensors can get a bit skewed and this calibration will reset the motion sensors on board the drone. However, for this to work properly, the drone also needs to be on an even surface. If you really wanted to make sure that it was as close to perfect as possible, you can try using a spirit level or you can simply place some tape rolls underneath the drone to make sure that it's leveled. Now press on the calibrate button and it should only take a couple of seconds. That's all done, let's move on to the next tab. Now go ahead and click on the configuration tab. This is the place where most of the general settings are. Starting with the mixer setting, make sure that the drop-down box says Quad X. You might remember from section 2 where I talked about the various drone configurations. This is a setting that lets Betaflight know what sort of aircraft you're setting up, in this case an X configuration quadcopter. As you can see from the diagram, it shows the placement of the motors and also which direction the motors should be spinning. The next thing we need to let Betaflight know is the type of radio receiver we're using in the receiver settings. As you might remember, we're using PPM with our receiver, so go ahead and select that from the drop-down box. The final thing we got to configure on this tab are the speed controllers. The speed controllers we're using in this build support D-Shot, which is a digital protocol. Besides the lower latency and better protection against interference, speed controllers that support D-Shot don't require calibration. The speed controllers that use analog protocols such as PWM, one-shot or multi-shot all require calibration of their internal clocks to the internal clock of the flight controller. And finally, another great thing that's been recently added to Betaflight is that there is simply less to configure when using D-Shot. Let's have a look at what happens when we select one of the analog protocols from the list. Let's take multi-shot as an example. The relevant settings to note here are these three. Let's have a quick overview of what they are before carrying on with the speed controller setup. The settings here are related to the radio system, specifically the position of the throttle stick, which is the left stick on a Mode 2 transmitter. The values set here are sent to the speed controllers to control the motors and the default values are usually fine to start with. Okay, so minimum throttle is usually set to a value on which all the motors will spin at the same time without any weird hiccups or stuttering. What this setting essentially does is make sure that the drone doesn't randomly take off if the throttle stick has been left above a certain level while arming the drone. Which is also why we set this to a value where all the motors can spin but not fast enough that the drone takes off. Next, we have the max throttle. When using analog protocols on speed controllers, the throttle values that are recognized by the system lie roughly between 1000 and 2000. So the default value set here is usually fine as well. Lastly, the minimum command. It is the lowest throttle position on your radio system. It's what the flight controller sends to the speed controllers when the drone isn't armed and doesn't want the motor spinning at all. Okay, so let's jump back to setting up D-Shot in the speed controller settings. The specific speed controllers we are using support up to D-Shot 600, so go ahead and select that from the drop-down list. Just below the speed controller settings, you can see the motor stop option. This is another safety feature and it bypasses the system default setting of spinning up the motors on low power as soon as the drone is armed. This setting is primarily a matter of preference. You will eventually form your own opinion about whether it's a good thing or not, but for the time being, I recommend enabling it. The last thing we need to have a quick look at is the motor idle throttle value. This value works similarly to how the minimum throttle value is set while using analog protocols and is done in percentage of full throttle. Ideally, we want this value to be as low as possible, However, the default value that's set here for now will work fine to start with. Okay, this concludes the configuration tab. For the time being, I suggest turning off all the options in the other features section as well. Then press save and reboot button and let's move on to the motors tab. In the motors tab, we'll do two things. First, I will show you how to calibrate analog speed controllers, since the one I'm using in this build with D-Shot 600 do not require calibration. Secondly, we'll spin up all the motors and make sure that they are working properly and spinning the correct direction. To calibrate the speed controllers, go ahead and click the I understand the risk button. Then slide the master slider all the way to the top. Now we need to plug in the battery, at which point the drone will make some funky music happen. After it finishes, slide the master slider all the way back down and the drone will make some more noises, at which point your speed controllers are calibrated. Next, let's have a look at whether our motors are working correctly. With the battery still connected, bring up the master slider slowly until all the motors start spinning at the same time. At this point, notice which direction they're spinning, whether it's clockwise or anti-clockwise. Bring the master slider back down and uncheck the I understand the risk button. Cross-reference whether all the motors are spinning towards the direction they're supposed to according to the diagram. Next, let's go to the receiver tab, and the main thing we need to do here is to double check whether the transmitter is working properly. Go ahead and plug in your battery again, which will power the entire system including the video receiver. Once done, power on your transmitter and let's make sure that all the channels are working as they're supposed to. The 4 channels that are important to make the drone fly are set up in something called a channel map. The default channel map in Betaflight works with the radio system we have. Finally, let's do a quick test of whether all the channels do what they're supposed to by double checking individual stick movements and the switches to see how they correspond on the screen. As we can see, all the main channels including the 2 aux channels are properly mapped, so we can move on to the next step. The final tab we're looking at is Modes. Here we will set up the aux channels to do something useful by defining an arming switch and a switch to flip between flight modes. Flight modes are simply preset flight characteristics that we can access at a flip of a switch. To start, in the row where it says ARM, click Add Range and then select AUX1 from the drop-down list, which, as you might remember, is switch A we assigned earlier when configuring the transmitter. Then push this range slider all the way towards the right. The range slider is divided into values. On a 2-way flip switch, you can toggle between 2 positions. On a 3-way slider, you can toggle between 3 positions. Next, we'll use the 3-way switch on the transmitter to set up some flight modes. By default, in case no flight mode is defined, the drone will fly in something called acro mode. This is a completely manual mode in which the onboard stabilization sensors don't interfere with the flight. This mode allows you to do fun acrobatic flight, but also requires a lot of practice and skill to fly. The way I like setting up flight modes on a new drone is that on position 1 of the 3-way switch, I like to keep it at acro mode. So nothing will be set up at position 1 of aux2. Next, in the row where it says angle, click add range and change auto to aux2. In angle mode, the drone will be using the onboard sensors to provide a stable flight. However, you'll be limited to a certain degree of movement. This mode is there for you to get a feel of the way the drone flies when you're just starting off, but it's also quite restricted. We can leave the range slider in the middle for this. Finally, in the row where it says horizon, click add range and change auto to aux2. Horizon mode could be thought of as a midpoint between acro and angle mode. It provides stabilization but also gives you a bit of a taste of how the drone might fly in acro mode. Set the range slider all the way to the right for this. Now this is just one way you can set up flight modes and you can change it to whichever way you like best. But to start with, I suggest you enable angle mode at the very least, since it will allow you to fly the drone with stabilization to practice with. Said that, your long-term goal should be to fly the drone in acro mode, since that's the most fun and gives you full control over flight. Make sure you press the save button and disconnect the flight controller. Thank you so much for sticking with me all the way through the course. You'll be happy to know that this is all the basic configuration we need to do to get the drone flying. Now before you run down the field to do a test flight, unplug the drone from the computer, Plug in the battery without the propellers attached and try arming the drone with the newly set up arming switch, followed with some test with the throttle stick on the transmitter to see if the motors respond. If the drone refuses to arm, make sure it's sitting as level as possible, since Betaflight has a setting where the drone will not arm if it's sitting on an angle that is too steep. If the arming procedure and the motor test works well, go ahead and take the drone out to an open place with the propellers attached and do your first test flight.